Love it. So good afternoon, everybody. My name is Jesse, and I am with Exploring by the Seat of Your Pants. For those joining us for the first time, we are all about bringing conservation, adventure, and science into classrooms around the world. And we are particularly excited this April because all month long, we are celebrating and showcasing climate research, climate change solutions, and more, all made possible by Environment and Climate Change Canada, who's sponsoring us to do that. So thank you so much to them. Right now, we've got 5 classes from across North America joining us, and online, the Laurel Spring School with hundreds of kids around the world. So thanks so much for joining us. I want to give them a chance to do a bit of a shout out before I introduce our speaker. So we've got Miss Oliverson's grade 3s in San Antonio, Texas. Hi, guys. Hey. Impressive. We've got Miss Carton's grade 2 and 3 joining us in Anchorage, Alaska. Welcome in, guys.
5 and 6, but that's good.
Different thing. That's okay. You can be whatever grade you want. I love it. All right. We've got Miss Camplin's grade 4s in Guelph, Ontario. Hi, guys.
Hi.
All right. And we've got Miss Ragsdale's grade 8 in Grand Junction, Colorado. Hi, guys. Hi. I don't know if we've ever had a Grand Junction class before. I haven't had one, so that's very exciting for me. So thanks for joining in, guys. And then Miss Miller's group, grade 5s in Brampton, Ontario. Hi, guys. Hey. Hey. Awesome. Of course, the reason you guys are all joining us today is for our speaker. So we are joined live in Hawaii by Barry Choy, who is a hurricane hunter. So for over 30 years, he has worked at the National Oceanic and Atmospheric Administration in a variety of jobs, ranging from diver to ship operator, weather forecaster, and more. But what you guys are here today to hear about is his job as a hurricane hunter. So while the rest of us are cowering and running away and trying to hide from hurricanes, Barry flies planes directly into the hurricane so that we can get a better understanding of their nature and save lives down the road. So without further ado, thank you so much for joining us, Barry, and take it away.
Aloha, everyone from Hawaii. And I know I can't hear you, but what I'll do is we'll go through a real brief presentation here, and I'll allow you some an opportunity to ask some questions. And so we'll get started here. What's that?
No, the whole restart thing is funny.
Oh, am I restart in the middle of this thing?
The job of a hurricane hunter is not for the faint of heart. These brave men and women must fly straight into one of the most destructive forces in nature. Hurricanes are born over the open ocean, and while satellites can track their movement, meteorologists and researchers need to sample the storms directly to get the most accurate information about them. NOAA's Hurricane Hunter fleet includes 2 P-3 turboprop aircraft, as well as a Gulfstream IV jet. The P-3s fly in the storm, encountering devastating winds that can be over 150 miles per hour. The jet can fly higher than the turboprops, gathering data from the upper atmosphere. Both planes have high-tech equipment on board to get the job done, like radar and fixed probes that measure particles in the air. Scientists also deploy drop Windsongs, which parachute down through the hurricane to the ocean surface, sending back data on pressure, temperature, humidity, and wind. These measurements can help us understand the structure of the storm and the winds that are steering it. The data is used in computer models that help forecasters predict how intense the hurricane will be and where and when it will strike land. Hurricane hunters take a literal look into the eye of a monster formed by nature. Their courage helps further science, which saves lives.
Well, while that video pretty much detailed what we do when we go out there and fly into hurricanes, I'll give you a little bit more of an overview of NOAA, the National Oceanic and Atmospheric Administration, and also what we specifically do as we fly into the storms and what it's used for. NOAA is a science-based service organization. Our mission is science, service, and stewardship, the science piece. We're trying to understand what goes on our planet, you know, the atmosphere, the oceans, the climate, and how those how the atmosphere and ocean works together. And if we can understand that, we can model it and provide predictions. Now, the service piece is if we know that and we can predict changes, what do we do with that? We share it with others through various means, and I'm going to share some information with you today. And that stewardship piece, if we see some of these train wrecks coming, the sea levels rising, the planet's warming, what do you actually do about it? Our fisheries are collapsing. How do we protect those resources so it's sustainable for the future? NOAA has a number of line offices, and there's just offices within the National Oceanic Atmospheric Administration. The two we're going to concentrate on today are the National Weather Service and the Office of Atmospheric Research. Also, the Office of Marine and Aviation and Operations is where I work, and we operate the ship and the aircraft assets for NOAA. Within the OMAO, as you see there, Office of Marine and Aviation Operations, there's a small group of commissioned officers like the Army, Air Force, Navy, Marines, and Coast Guard. There's the NOAA Corps. And we are commissioned officers just like all the other branches of service. And we run the ship and the aircraft for NOAA. There's a number of other line offices, as you can see there, our Environmental Satellites Information Service, our Ocean Service, and our Fishery Service. We won't touch too much on that this morning here and afternoon where you're at. So here to talk about hurricanes. This is a very nice graphic someone prepared from the 2005 season. And what you'll notice there are that hurricanes can be strong and small or weak and large. And, you can see the different sizes of the storms. This is a mosaic of multiple storms all placed on one map after the hurricane season. And you can see we got some pretty small storms here like Emily, but very intense, as you can see by that eye structure when it's really defined like that characterizes a very strong storm. And then you can see Katrina, which is a relatively large storm. It takes up almost the entire Gulf of Mexico there. Storms are categorized by wind speed. However, as you'll see in a minute, most of the damage and most of the lives lost are not directly from the wind, but the impacts of wind on the ocean and the rainfall. This is just a chart on all the different wind speeds. On the left, you'll see the miles per hour. Category 3 and higher is called a major hurricane. And you have really significant damage with those storms above the 3. Of course, flooding is a big issue. This is from Katrina down in New Orleans. You can see some of the flooding issues that are experienced. Almost 80% of the lives lost are typically due to drowning and flooding. Storm surge is another big hazard from these storms. You'll see this large ship that was in a shipyard there on just put right up on shore. This is a several hundred ton ship just placed on shore. These are the casinos after Katrina on the coast of the Gulf of Mexico in Biloxi. This casino here, if you look in the bottom of the screen, that little square, you'll see there's a pirate ship. It was sort of a pirate ship casino. And while the building looks like it's intact, if you notice right here, the first couple floors, the storm surge was so strong, it blew right through the building, and you would see all this debris back in here, and it cleared the parking lot out of any trees or anything that was in there. And so while some of these buildings look like they're intact, they have sustained a lot of damage. Here's another casino in that Biloxi area, and you get the idea that these storms are quite devastating. One thing that I wasn't expecting is when I flew over Lake Pontchartrain after Katrina, this road that goes across the lake here, I was surprised that those concrete sections of the road were all lifted up. It almost looked like dominoes. And so the water is very powerful, and it can cause a lot of damage. And so why do we take these planes into hurricanes? One is better forecast saves lives, and that's the number one reason we do it. Evacuations are quite costly and disruptive. As you can imagine, if we can limit that evacuation area, we save a lot of money and a lot of consternation for the folks who live there. And it's essential for our numerical prediction models, and that's the tool that our forecasters use to better predict the track, the intensity of the storm. We want to know where this thing is going, when it's going to get there, how large it is, and how strong it's going to be. We also to be able to prepare better and provide better predictions is we have to understand the structure of these storms so we fly into them. This is just an example. Back in 2003, if we were warning for this particular storm, and we did, how much of the coast would have to be warned. And as our predictions have gotten better over the years, we did the same calculation in 2010, and we were able to narrow that to a much smaller area. So you can see using aircraft observations and all kinds of observations beside aircraft and the prediction models that we have today and the skillful forecasters really improve that prediction. This is a hurricane. If we took it and we cut it in half, took a cross section down it, you'll see that eye structure in the center. That eye forms because there's sinking air in that location. And then you'll see a number of these rain bands that extend out from the eye, sometimes over 100 miles. And as we fly into the storm, we have to go through these successive rain bands. And that's typically where you have a lot of really bad weather. And then in this eye wall is typically where you have the strongest convection, we call it, or the thunderstorms. This is a tail Doppler radar shot. The aircraft is right here in the middle of the storm. And you can see these towers of thunderstorms in the eye wall extend up to 50,000 feet. Here's a graphic presentation of a cross section of a storm. And you can see how that rainfall forms within the storm and where it's at in the core and elsewhere in that storm. What we'll look at here is an animation of Hurricane Katrina, and what you want to look at carefully is watch as that storm proceeds. Watch behind it. This warm colors are warm water, and you see it actually cools the water behind it. What happens is a storm moves over the warm water. If there isn't a really deep mixed layer, it upwells cold, cooler water, and it can weaken the storm. And we actually flew ahead of Katrina and dropped some SONs. They call them AXBTs, Airborne Expendable Bathythermograph buoys, to look at the water column and see how deep that mixed warm layer of water was. And we and the forecasters forecasted the storm to weaken, which it actually did as we were flying it offshore. It was a Category 5 storm, and we'll see that in a sec. This is what it might look like as we fly toward a storm. It's pretty uneventful, except you can see where it's at. You see a lot of lightning there in the distance, and we're headed out to the storm. And that's typically what we see from our office view in the cockpit as we head toward a storm. Tell you a little bit about the tracks that we fly. Two different types of aircraft, as you saw in the video. The P3 flies that blue track, sort of a crisscross through the storm, as you can see there. And then the red track is what the G4, the high altitude jet, will fly. And these are what those aircraft look like. So the P3 flies down and in the storm. The G4 flies around the storm. You can think of the storm as a cork in a river. There's an atmospheric influence to that storm that actually moves it in various directions. So you really have to know that environment that storm is in. The upper level wind flow can actually affect where that storm is going. So we measure that with the G4 aircraft. Here's what the aircraft looks like and some of the features. You'll see on the belly, there's a radar dome, the C-band fuselage radar. We call that the big M&M on the bottom of the plane. And that can look out around the aircraft, as you see in these the lower images here. The belly radar on the bottom left, and that's what you would see from inside the aircraft. You can see the eye wall structure and all the rain bands as you head out. That tail Doppler radar above, as you've seen, it can do a cross-section of the storm. And that same image that we showed earlier is on the top right corner there. We also use drop wind SONs. And you probably heard of weather balloons. We launch weather balloons to see what's happening in the upper atmosphere. And that information goes into our models as well to help the forecasters provide a better prediction. Well, in a storm, we can't really launch weather balloons from the aircraft. So what we do is we do it in the opposite direction. We drop a SON with a little parachute on it. And as it's falling, it collects wind speed, wind direction, humidity, temperature type information. And here's one being launched out of the aircraft so you can see what it actually looks like. Drops on operator there, puts it in the tube. And we have a little valve in this area right here, and the aircraft is pressurized. So the pressure, air pressure in the aircraft is higher than outside. So we open that valve and that it shoots the sound out of the aircraft. And we can see what that looks like when it comes out of the aircraft. And you'll notice in this section right here, watch very carefully because it's really small. In a few seconds here, you'll see it pop out of the aircraft right in this lower fuse. There it went. So hopefully you were able to catch that, and your classrooms have enough bandwidth that the videos are playing at the same speed we're playing them here. Now, why do we do this? Here, this is Katrina, and this is the best track. The actual track that the storm made was in black. The forecasters predicted it to go along this track here in green. And if we didn't put any of those drop sondes in, this is what they would have predicted. So you can have quite a big difference in your forecast skill just by using those sondes alone. We'll look at Katrina a little bit. This is a belly radar image of an eye wall replacement cycle, which is kind of neat because you have two eyes. And who would have thought that these storms, as they go through these replacement cycles, actually have an eye within an eye, which you don't typically see on your television. So your newscasters are sharing some of that NOAA information with you. From the cockpit, we have a radar that we can look at the storm as we head into it. And this is what it looks like. This is the eye right here, the eye wall itself. This is the eye, the black part. And the aircraft would be located right here, headed into the eye. And you can see it's a little offset to the right. What's happening is the wind speeds are really strong in this direction. So we have to kind of turn the aircraft to the left a little bit here to adjust for the wind so that we go right into the center of the eye. That's what you would look like if you were in the center of the eye and you look at, here's the eye wall from the center of the eye. And to give you an example, this is what the aircraft operators, your airline pilots have, this similar radar, and they only fly in the green. They stay away from the yellow and the red, and that's what we fly into. And now what I'll do is I'll show you what it's like to fly into the storm. We're right at the edge of the eye wall of Katrina right here. That's the eye itself, that black part. And we're going to head into the eye wall, which is the most intense part of the storm. And you're going to see it start getting pretty bumpy. The co-pilot's on the right, the pilot's on the left, and this person in the middle here with the white gloves is the flight engineer. So it takes three of us to really operate this plane. The pilot and co-pilot are taking turns at flying the plane into the storm. Well, one backs the other one up in case something happens and they have to take over. These are your engine instruments in the center panel here. Some of your environmental instruments on the overhead. The flight engineer is maintaining the power settings because we have to fly at a specific speed. If we go too fast and we get bounced around too much, you can actually cause cracks in the wings and damage the aircraft. And if we go too slow, we can have aerodynamic stall or engine stall. And that is not good as well. So in a little bit, we're going to fly through this eye wall and into the eye itself. As you can see, nothing out the windows because the rainfall is so intense. And you can see you bounce around quite a bit. As it clears out a little bit, you're going to see a little probe here. We have instruments on a probe. You're going to see that start up here that sticks out about 10 feet in front of the aircraft. And then you're going to see that beautiful eye structure. We call it the stadium effect, where the clouds slope up to, say 50,000 feet all around you. And this video doesn't do it justice, but it's a really magnificent sight. And you can see typically all the way to the surface of the water and all the way up out of the eye of the aircraft. And you're going to see what that looks like right there. You can see that sloping cloud structure up to higher levels. And in the eye, the winds are calm and they go to zero pretty much. And so we can let people up and let them walk around. And then we set the seatbelt sign up again and people sit down and we'll go right back out the other side of the storm to measure the other side of the eye wall. And so I'll let this run for just a second more because I think there's a really good shot of the eye. And then we'll go and wrap up and I'll let you ask some questions in case I didn't cover something that you were interested in. We do sustain a little bit of damage. Rainfall itself wears the paint off the plane. It's like sandpaper or sandblasting. If we get into hail or graupel, it can actually make small holes in the leading edges of the wings, and we have to patch those before we go out. Occasionally, we have some major problems. This was in Hurricane Hugo. Our crew actually lost 2 engines, and it really turned the cabin upside down a lot, and a lot of things broke loose, and we almost lost that aircraft. So it's not completely safe, but we do it because it saves lives. We're also experimenting now with unmanned aircraft to take the place of the G4, or perhaps someday take the place of the G4. This is the Global Hawk. It flies at a really high altitude, and it can handle that surveillance mission the G4 does, flying around the storms. We've even flown one of these over a storm, but it was less than a Cat 3 level storm. We also have these small UAVs. There's unmanned aircraft that we can launch from the P3 that they can fly down low in the eye of the storm. This is the Coyote. And we've launched a few of these. They're quite expensive, and we don't get them back. They're about $30,000 a piece, so we don't launch too many of those. And with that, I just wanted to share a little tool with you that NOAA has. If you wanted to go and look up hurricanes, the historic hurricanes that have occurred anywhere, go to this tool. And I think the website is on the bottom there. And you can go and click on these hurricanes and tropical weather systems, and they'll tell you when they occurred and where they impacted. That's my contact information. Feel free to take that down, and please email me if there are questions I haven't answered. I know we have a limited amount of time and a lot of folks out there, so please go ahead and feel free to email me if you have any other questions that we don't answer today. And now I'll be happy to take questions.
Outstanding, Barry. I've done 300 of these. That was one of the coolest presentations I've ever been a part of. So thank you so much for that. And yes, we'll pass along your email to the classes as well, because I can actually assure you there'll be more than we can cover in 15 minutes. All right, guys. For the groups online, I know we've got a lot of kids watching there too. If you want to type your questions in the YouTube chat bar, I'll pass them along, so please do that. But for now, we'll start with Miss Oliverson's class. If you guys want to kick us off with a question, come on up. Yep. Hey guys, Miss Oliverson, there you go. Come on up. There you go. Hey.
How much planes have you sent up in a hurricane?
I'm sorry, I didn't hear that.
How much planes have you sent up in hurricanes?
Oh, how many aircraft that we use in hurricanes? So we have 2 P3 aircraft and the 1 G4, the jet that you saw. That's NOAA's contribution, and the Air Force has 10 C-130 aircraft that they provide reconnaissance support.
Okay, thank you so much for that. Just so you know too, Barry, the computer with the camera that's actually viewing right now is on just to your right. So if you want to look into just, I don't know, just wanted to know. There you go, Bert. Miss Carton's class, if you guys have a question, grade 5, 6s, after all. There we go.
We have one coming up.
Perfect.
No, are you sure? Okay, go ahead, Alexander. Hop on up. Make sure to push the computer screen back so they can see your face.
Yep. Take your time, guys. All good?
Well, what made you what inspired you to do this job?
Yeah.
Yeah.
Oh, hey, that's a really good question. I went to the University of Hawaiʻi here, and I studied meteorology, and so I became a meteorologist. And I had several jobs along the way within NOAA, and eventually I started flying aircraft for NOAA. And you don't start out flying into hurricanes. I flew an airborne snow survey up in the Midwest, which you'll see that is very important right now. We measure how much water's in the snowpack using aircraft for spring melt flood forecasting in areas like Grand Forks and up in Fargo, North Dakota. And after flying that for 5 years, they asked if I was interested in flying hurricanes, and I said, yeah, I was. And that's how it happened. I like to say I had some kind of master plan, but I really didn't. It sort of happened for me, but it was right in line with what I studied, and it worked out very well.
Outstanding. All right, so Miss Camplin's class, if you guys want to come up, just demute your mic, and you'll be good to go. I'll let you know when you're all ready.
Okay.
You're good.
Here? All right.
Yep.
Isaac. All right, Isaac. Why is it called in the eye of the storm?
Oh, that's another very good question. You see that very characteristic eye. The winds, the actual air motion is downward in the eye itself, So it has to go to zero at some point, right? Because it's a little spiral, and the wind's going around in a counterclockwise direction in the northern hemisphere. And so as you get to that center location, the winds decrease as you head there. The eye wall itself, the winds are very intense. I didn't talk about this, but in that eye wall shot that we flew through just in that video, the winds were at 164 knots. So, over 180 miles per hour at flight level, which is very low, really, about 5,000 to 10,000 feet, where those, those eye wall clouds go up to about 50,000 feet. And as soon as you break out of that eye wall, the winds drop off significantly, maybe to about 30 or 20 knots. And then as you proceed toward the center, there's a zero wind point in the center of the storm somewhere. We try to find that, and we drop a SON right in the center to get the minimum central pressure.
Wow, very cool. All right, Miss Ragsdale's class, if you guys have a question, come on up. You're good to go. Yeah, I was able to demute you for some reason now, so you're set right now.
Okay. Are there future NOAA satellites going into orbit soon?
I've kind of lost the schedule, but we have one that was recently launched, and then we have our new GOES-R, I think, which is providing, in fact, they renamed it. After they launch it, they name it a number, a GOES, 17. So we have a number of geostationary satellites that are up there, and some polar orbiting satellites that provide information. And in the Pacific, we do not typically fly many storms in the Pacific because we don't have the resources to do it. So all of your hurricane intensity and forecasting comes from satellite, using satellite data. We use an analysis called a Dvorak analysis, and that gets you pretty close. Flying in the storm is the best information you can get, but it gets you pretty close. And we constantly have satellites being developed and launched. And so I don't know what the schedule is, but if you go on our NESDIS site, NESDIS, the National Environmental Satellites Data and Information Service site, they will have the latest schedule on satellite launches and what's up there now.
Okay. All right, we'll take our last of the first round of questions from live classes. So Miss Miller's class, if you guys want to come up, just demute your mic and we'll be good to go. You're good.
Does climate change have a role in hurricanes?
We believe it does. Recent studies have shown that globally, and we'll use hurricanes, typhoons, cyclones, they're all the same thing. Tropical weather systems, just different locations on the planet. We call them different things, right? We show globally that with the warming climate, we may see slightly fewer storms, but they're probably more intense more intense storms. So stronger, but fewer storms.
Excellent question. Glad we got to that. All right. I know Miss Miller's class and Miss Miller's class and Miss Campbell's class have to go soon because it's the end of their day. So thanks for joining us Eastern Time Zone classes. So we'll go to them back before we take some online questions, actually. So Miss Campbell's group, if you guys want to kick us off with a second question, just demute and come on up. You're good. Yeah.
This is Bronwyn.
What was the biggest hurricane out of all of them? Which one was the biggest?
Yeah.
Oh, that's going to test my memory here a little bit. I would say the strongest storm, and we didn't fly this storm because it was in the Pacific, that I recall, at least in recent times, 2013, I believe, was a Typhoon Hagupit or Haiyan, which hit the Philippines. I think they clocked winds near 200 miles an hour at the surface, if my memory serves me correctly. We flew a really strong storm, and I flew this storm, I believe, in 2005. It may still have the record at the time. I think it was the record. Was Hurricane Wilma in the Atlantic. It was a very interesting storm. One of the problems that we have is forecasting rapid intensification. So storms that really develop rapidly. This storm went from, if I remember correctly, from a tropical storm to a Cat 5 hurricane in about a day, 24 hours. It was really one of the most rapid intensifying storms we've ever noticed. And I think it may still have the lowest central pressure record. I have a meteorologist here might know.
I don't know right
in the room. She doesn't know. But I think it was Wilma in the Atlantic. And so you can go research that on that website and see what the minimum central pressure was and the winds. Wilma was relatively small, but it was very intense. And I remember flying it over the Yucatan Peninsula. It was one of these storms that sat over the Yucatan, and we always predicted when storms go over land, they typically weaken very rapidly. It sat over the Yucatan as a Cat 3 storm for about 72 hours, which was very uncharacteristic. And we flew that thing, I remember, night after night over the Yucatan.
So just for the classes, just quick follow-up. You mentioned that it went from a tropical storm to a Category 5 in one day. What's a typical storm progression if it gets up to a Category 5? How long would that be drawn out over?
Yeah, it's usually over several days, and usually the models handle those types of intensifications relatively well. We still don't have a good grasp on this rapid intensification, and the implications of that could be devastating. Let's say we were predicting a tropical storm to come ashore, and you were prepared for that the night before, and by morning it's a Cat 3 hurricane. So, a lot greater impact, obviously, with a Cat 3 hurricane, and you wouldn't necessarily be very well prepared. And so that's kind of, the things that keep us up at night. How do we get better at that rapid intensification forecasting?
Thanks. All right, we'll go back to Ms. Miller's class for a second question. If you guys want to come on up, and then we'll take some ones from online. So yeah, just demute guys when you're ready, and I'll let you know when you're good. You're good.
How are the airplanes used for NOAA designed?
Yeah, that's a real good question. Everybody asks, hey, do you actually put extra structures in there, and do you strengthen the aircraft to be able to do this? And the answer is no. These are production P-3 aircraft, which the Navy developed to do anti-submarine warfare primarily. So they were built very well, but we didn't put any additional structures in there. Of course, we have a significant amount of equipment mounted on the aircraft and sensors and these types of things. So we do put a lot of different types of equipment on there that the Navy doesn't use, but the wings and the aircraft itself are not strengthened in any way. However, we did find a lot of issues in the wings, and the Navy has as well. So we have re-winged one of our aircraft, and we're going to get our other one re-winged as well. And so they'll have brand new wings. So basically a zero-time aircraft again, like a brand new plane. Yeah.
Still though, that's the ultimate testament to airplane manufacturers, that they can be built just naturally to withstand a hurricane. You should sell that. Boeing would love to know those results. All right, let's take some questions online, guys. Zane wants to ask, what is the least favorite and favorite part of your job?
Well, I think the least favorite part of my job is I had to stop flying hurricanes at some point in my career. So I really don't do that anymore. And but the favorite part was flying and doing that particular mission. It was very rewarding to see the results of what you had done the night before, and provided that input to folks, and so that they were better prepared and saved lives. Now, when I was flying hurricanes, the least favorite part of the job was probably whatever we had to do when we weren't flying, and that we have a shore-based job. So at different times in that period, I was the chief of maintenance, so I had to be in charge of all the maintenance of the aircraft and all of that. And those are really difficult jobs. Flying is difficult in a different way, but much more enjoyable and I thought rewarding.
Okay. Ting wants to ask, what's the fastest plane you have, and how fast does it go?
Yeah, the Gulfstream 4 jet is our fastest plane right now, and it'll fly at your airliner speeds, in excess of about 500 knots, or maybe 550 or so miles per hour. I have not flown our G4. I flew the P3 aircraft, and it's a relatively slow plane as far as planes go. We fly at about 300 miles an hour. When we're going into the storm, like I said, we have to fly a slower speed so that the turbulence doesn't damage the aircraft. And we fly at about 230 or so, 240 miles per hour as we're going through that eye wall.
Yeah. All right, Rebecca had a question, and I suppose the answer might be no to this, but it's something you touched upon in one of your pieces in your presentation. Have you personally ever been in a plane crash or something where something went wrong in the aircraft? And can you speak to that?
No, thank God. Yeah. No, I haven't been involved in a plane crash, because that would be a lot of people don't make it out of that. And in hurricanes, you wouldn't have a chance, really. Now, have we had malfunctions? Now, that's the most dangerous part of flying hurricanes. It's the plane can handle it, the crew can handle it for the most part. It's if you have something that complicates things, a malfunction. And we've actually had some malfunctions that I thought were relatively serious. We put in some new equipment at one time, these new screens up in the cockpit. And these screens are, high tech, sort of like your computer screen. We can put anything on there. We can see what data's coming in and all of that. And they're supposed to last 100,000 hours or 200,000 hours before you have to fix them. Well, after about 3 hours and into a flight that we were headed out into a storm, one of them caught on fire, and in a flight station, that's pretty serious. And not flames, but smoke, and then that, obviously smoke in an enclosed environment, smoke inhalation is very dangerous. So we had to neutralize that. And we practice, we have a lot of procedures, and we go through our procedures, disconnect it from the power, be ready to put it out with a fire extinguisher, and we're able to neutralize that. And we actually continued that flight, and we're able to be successful. But that's when it gets sort of scary.
I think it's a testament to professionalism generally, and as a team and as an individual, that you had part of the plane on fire inside, and you continued on with the flight just the same. So I want to thank you for that on behalf of all the people saved by the work you guys do. All right, let's take 3 last questions, guys. Miss Ragsdale's class, if you guys want to come up,
who's doing it?
You're good to go. If you have a second one.
Come, Riley.
No hurry, all good, guys. There you go. Oh, you're muted. Sorry, no, you were demuted. Now you're good. Go ahead.
Okay. Is the research happening currently in Hawaii?
So we have 2 types of missions. NOAA does. The Air Force does the recon. So the typical every so many hours we have to take a fix in a storm if it's going to hit the U.S., right? And then we have a research mission. So typically, if a plane comes out to Hawaii and flies a storm, it's doing the reconnaissance for a storm that could impact Hawaii. Although we have done research missions out here in the past for other things like atmospheric rivers. We've done a marine pollution experiment where we flew very low out here over the Pacific to document the garbage patch in the North Pacific and things like that. So I can't remember a hurricane research project in Hawaii, but we do reconnaissance where we actually fly if a storm is going to impact the islands here.
All right, let's head to Miss Oliverson's class. And if you guys have a question, come on up.
All right, you guys speak up.
My question is, when you guys are driving, and then when you guys drive into the hurricane, does anybody got hurt or something?
Oh, has anyone been hurt? I haven't been on a flight where someone's been injured. Typically, the worst thing that happens, and it happens to a lot of people, is they get airsick, like being seasick. And so we have, bags and stuff for them so that they don't mess the plane up. There have been flights, and I know of one for sure where someone was injured. We also do these big thunderstorms that occur in the Pacific, in the Midwest and in the continental United States. Some of you are probably live in areas where you've had tornadoes and things of that nature. We occasionally do research on those storms, and we don't fly into them, but we fly around them. And in one storm, I know the National Center, what is it called? The National Center for Atmospheric Research, NCAR, they have an aircraft, and they were upset in the rear flying downdraft of one of these big thunderstorms, and it injured someone pretty badly.
Yeah. So certainly a risk, as you guys laid clear in earlier in the presentation too. All right, we'll wrap up with a question from Ms. Carton's class. If you guys want to end us off before we do a final message, go right ahead.
Who was the first person to fly into a hurricane?
Wow. I don't know the answer to that. There is actually, I looked this up recently. There's a really good web page that talks about the history of flying into storms, and it documents the entire history. It may be on there. And so if you do a Google search on the history of flying into hurricanes, you may be able to find it. And when you find it, send me an email. I would like to know that as well.
We will try and track that down for you. And a great question, because this is something that, you know, with years of experience, I only found out about a year ago. So for the classes today, it's a real treat to have you here. Barry, before we wrap up, is there any last message you want to share about where kids can learn more? We're going to pass along your email to fill in with the many hundreds of more questions, I'm sure. But anything else where we can guide kids to learn anything else?
Leon just brought up the website here, and it credits Joseph Duckworth with being the first person to fly into a hurricane. And to answer your question, NOAA, NASA, and some other government organizations, as well as the National Center for Atmospheric Research or the University Centers for Atmospheric Research, UCAR, have a lot of information on the web. Some of it is a little challenging to get to, but I would advise your classes, when you have some time, go on the web and explore. And if you have some questions on flying into storms, you know, write to someone like me, or you may find it on the online as well.
Outstanding. Well, Barry, what we do at the end of every hangout, I'm going to demute every class's microphone. So Miss Alderson, Miss Carton, Miss Raisdale's class, the others had to leave as their parents came to pick them up. But if you guys could join me in saying a huge thank you to Barry for joining us today. Go right ahead. Awesome, guys. I appreciate all the classes for joining us today. Barry, thank you so much for joining us. An absolute pleasure, and we hope to have you back soon.
Thank you.
All right.